That understood, we can now consider production. How do we use all this stuff? What will our process of production be? And what do we need to consider to make sure it is as optimized as possible to maximize our sustainability? Well, the first thing that jumps right out at us is the fact that we need to constantly try and preserve. The planet's resources are essentially finite, so it is important that we be strategic. Strategic preservation is the key. The second thing we recognize is that some resources are really not as good as others in their performance. In fact, some of this stuff, when put into use, has a terrible effect on the environment, which invariably hinders our own health. For example, oil and fossil fuels. No matter how you cut it, they release some pretty destructive agents into the environment. Therefore, it is critical we do our best to use such things only when we really have to, if at all. Fortunately for us, we see a ton of solar, wind, tidal, wave, heat differential and geothermal possibilities for energy production, so we can strategize objectively about what we use and where, to avoid what could be called negative retroactions, or anything that results from production or use that damages the environment and hence ourselves. We will call this strategic safety to couple in with our strategic preservation. But production strategies do not stop there. We are going to need an efficiency strategy for the actual mechanics of production itself. And what we find is that there are roughly 3 specific protocols that we must adhere to. 1. Every good we produce must be designed to last as long as possible. Naturally, the more things break down, the more resources we are going to need to replace them, and the more waste produced. 2. When things do break down, or are no longer usable for whatever reason, it is critical that we harvest or recycle as much as we possibly can. So the production design must take this into account directly at the very earliest stages. 3. Quickly evolving technologies such as electronics, which are subject to the fastest rates of technological obsolescence, would need to be designed to foreshadow and accommodate physical updates. The last thing we want to do is throw away an entire computer system just because it has only one broken part or is outdated. So we simply design the components to be easily updated, part by part, standardized and universally interchangeable, foreshadowed by the current trend of technological change. And when we realize that the mechanisms of strategic preservation, strategic safety, and strategic efficiency are purely technical considerations devoid of any human opinion or bias, we simply program these strategies into a computer which can weigh and calculate all the relevant variables, allowing us to always arrive at the absolute best method for sustainable production based on current understandings. And while that might sound complex, all it is a glorified calculator. Not to mention that such multivariate decision-making and monitoring systems are already used across the world today for isolated purposes. It is simply a process of scaling it out.